Hello and welcome back. It's time for, since a long time, another Modalis tutorial. Well, why? Because there is a new version of Modalis out. You can download it on the Forum IRCAM site. And after my last tutorial series, which I started as a complete unknown, the IRCAM reached out to me and they have officially made me important person. So I can barely leave the house because crowds are harassing me for my autographs because of these awesome tutorials. Um, well, of course not. A big thank you to Robert Piechot, the programmer. He took the time of day to explain to me a few things in the new version of Modalis. He even put my tutorials here in the extras, and there are still, of course, these instrument series. And he also took the time to explain me a little bit about the new God object in Modalis, which is called Lua. Lua standing for this language, scripting language called Lua, which is really cool. It's actually, I think, also quite popular for some game designers. I didn't know it before, but it's kind of simple to get. They also have a new documentation. So beside being compatible with the newest OSs now, they have a new documentation where you can finally search. And they already are building in, I guess it's still a work in progress, but they're already building in some really cool things. So like for different functions, how they work in Lisp, but also how they work in Lua, which we're gonna look into now, because Lua gives us the possibility in Max to build 3D objects. That's what we always wished for. Not the only thing, but it's a pretty powerful tool. So I'm still trying to get my head around it. And so when I looked the first time at one of these examples, I thought, well, I'm an idiot. And when Robert Piechot took the time to explain to me, I thought, I feel like a monkey now. um, Not completely, but there are a few things to get around. So this Lua object here is building in this example a 3D donut because people are hungry. And if you go in, you see this code, how it is done. So instead of having, I'm more of the documentation kind of guy, I have to admit. But while they're still working on the documentation, they decided to put out some examples. And when I looked the first time at these examples, I thought, well, that's that's hard. So I decided for this tutorial to try to make a really even simpler example to get things started. Who knows if there's some more tutorials in the future. I will see if I get to it. And yeah, so let's try. You might remember this 3D tutorial I already had where I made a simple bowl. So let's try to do the similar thing, just a simple bowl and rebuild it. And because this editor of Max, and this has nothing to do with Modalis, please, this has to do with Max, which has this editor for the JavaScript objects and for all other objects, and it sucks. It's a really shitty editor if you're used to some other editors. So I'm moving over to Atom, and Modalis has some, so this Lua object has some attached things. So if you go to your file system, to where you have your Max things stored, your external libraries, the packages in Modalis, if you go here, there is actually this and this. So these are two files with basically these Lua functions which I defined in Max. So they can, for those of you who are more prone to coding, give you a sense of, you should really not change anything here, but they can give you a sense of how certain functions work. So let's get to it. So I'm gonna make a new object, a new file here, and I'm gonna start a max patch there. So let's see here. So we need a button, and I'm gonna really simplify it, like super simplify. So I'm gonna make a very simple mlist.lua without two inputs, so no dynamic input, nothing, even simpler. It needs kind of, as far as I understood, there's just a kind of a wrapping building object, which is called mlist collector in this case. And there is, of course, as always, the script. And last but not least, of course, always the modalist object. We will see if we need some extra gain, some extra gain as it is here in the example. We'll see about that. And we need an easy DAC. There we go. Okay, so now let's start with with Lua. So if you double click on Lua, it already shows you a kind of base code, right? So it already has this library of these tools functions in it, and it has two functions. It might look familiar for those of you who have looked into Unity once, where there is always a start and an update function. Also others available, but it's kind of similar to that. So there is an initialize function and an update function, and the update function is really powerful. You can set it to run every single sample. So basically it opens up to all kinds of filter designs and all of that stuff, similar to gen tilde in Max, I guess, to a certain degree. So I will just copy that because I don't want to edit here. It's easier to edit here. I will set this to Lua. You can download, Atom is for free, and you can download this Lua color scheme. So how do we start? So let's keep to this example and see how we can simplify it and what we can leave out, what we need, and so on. First, we need a function to build the object. So I'm gonna make a function. It's gonna be called build bowl, I guess, and it's gonna have a name. I'm gonna do the same here, and this function at some point has to end there. There we go. Okay. At the same time, if I want the result of this function to see this work, I need to call it in the initialize function. So here I will have here something similar to this. So let's call it final bowl equals build bowl, and let's give it a name. The final bowl. Yeah, I will give it the same name. This should kind of call it, and we should be fine. So it has to evaluate here. Okay, let's start with a curve. So instead of the simple point that the single point that you might remember from Modalisp if you followed the last tutorial, here we start with this curve. It's basically a mathematical function which is drawn between 0 and 1. It's even written here. We're going to just copy that. We have a local, which is a variable call in Lua. We are going to call it curve, and equals to parametric curve 2D. So that's the function. And we make a new curve, which where we can define a scale. In Modalist, the scale is in meters. So if I say 0.5, it's going to be half a meter big, and if I say 1, it's going to be 1 meter big. So let's go for 0.5. That's already quite a big ball. Then there is a resolution, which is exactly what it says it is. let's put it at 20 as well. And then comes the mathematical function f equals function of t, which returns for x value, so it returns an x and a y value. So for x, what Robert actually told me is that Modalist doesn't like very much if the bowl is closed at the bottom. It works much better. It could become kind of unstable, I guess. So and the modes are very difficult for it to calculate. So it's better for now to leave a little tiny hole. So we are going to start off like 0.05, and the y value, let's make it a bowl which is exponential, so t times t, so the square of t, and end this. I think that's all. Yes, end. Okay. When we have defined this function, we can go over to create this local M for a mesh. I would call it the same. I guess you're free in how you call it, but I would call it the same. So I take this curve and I create a mesh from curve, which is a function. And there we already are. So we have our first mesh. And if we call this, we can then evaluate it or look at it. So I will take modalist.view M there. So, and this should work because I'm calling this function here in the initialize function, which is running at the start. So I'm gonna just copy this, go over to my patch, open here my editor and paste my new code. I never know how this saves. If I press the command S, it just gives a boop. So let's see. So let's try this out. Let's see if we see something. Oh, string 10 atom global x a nil value. I probably made a mistake, right? So I should have here t, of course, for 0.5. So here we go. So here we go. And we have our line, which is great. I'm just going to correct it here. That's a stupid mistake. And I can look also at the grid, which is for now like this. So if I zoom out with Z, with Shift Z, I can zoom out. We can see our function. It's basically, it starts a little bit off, and then it's plus 0.05, and it's, so this is X and this is Y, which I find still a little bit strange. I would have expected the grid to be like this and this line to go upwards, but I guess as long as you know how this works, it should be fine. Okay, so now we can make the bowl. So we need this rotation, and this actually looks a little bit for me like what we knew from Modalisp, where we kind of do the rotation, the duplicate rotation thing. Here we have modalist.extend mesh, and the method is rotation. Which mesh is it concerned is also here. It's M. If you have called this differently, you should take the same name here. The number of steps I didn't declare before here, so here in this example it's declared before, so it's easier to and more convenient to change later. But I will make steps equal, let's go for 20 here as well. Around which axis, if I remember right, axis, it also here should be 0, 1, 0, and the center should also be, I think, 0, 1, 0. let's see. I often have the impression I'm losing my orientation in these things. And the angle, let's put it the whole way around, so 360 degrees. Let's let's copy that, put it into our code here, save and evaluate. Yes, we have our bowl. You see? Great. So now we can kind of start to figure things out. You can even shift click. The M-edit, as you can see, is completely overhauled, which is great. So we can see, oh, here the quad 16 is 36. That's great. As you remember, so that when we strike the bowl, we don't want to, as you might remember, it to float away into nothingness. So we need a hold function, which is basically blocking a node in place. And they have that here in this example too. And I'm going to do this as well. So let's make a local hold equal to modalis dot create mesh here. The kind is in this case restrict line. The mesh is still the mesh M. The vector is, I guess, here as well, 0, 0, 1. Oops, I made a mistake here. This should not be here, it should be here. Okay, and the point 0, 0, 0. Let's see if that works. Point equals 0, 0, 0. And I will take that, copy it, go to this, paste it, and close, save, and see if that works. Okay, it doesn't complain for now. It really doesn't complain. We could actually make it show us the hold. So let's try this. I will just directly, in this case, do it here. And this Lua show the hold. Okay. Close, save, and yes, it's holding down here. So it works. So you see, it's a much nicer thing now in M-edit. It's great. Very, very cool function. Okay. Next, how are we going to proceed? So I'm going to close M-edit for now again, and we have the hold. We have this. So this nil, it's like a security, and nil is similar, like it's nothing. So it's similar to what you might know from Lisp. We are going to do, for security reasons, the same. So local, I'm gonna call it object as well. No, I'm gonna call it bowl. Bowl equals nil. So that's why what I define first. No, hey, nil. That's what I define first before making it. They have defined the thickness here. I will go around it for now to make it, I guess, to a certain degree, I don't know, simpler. So bowl, now I have to create that object. So modalis create object. And here we need a name, some name. I'm gonna just write name as well. The kind is, in this case, a finite element. Here we go. The mesh that we are using here is still M, so we are making an object out of that mesh, and now we are defining what material it's made of and all that. So it has a block function, which is the mesh hold. Yeah. Oops. Here, hold. It has modes, so be careful with these modes. The more you have, the longer it takes. So 60 modes is already pretty good. I'm gonna go a little bit deeper now because then it doesn't load too slowly. I'm gonna continue here. The thickness equals, yeah, 0.01 is a good thing. Density, I'm just gonna take the same here, 2500. The young, and you might remember from previous tutorials where you can find all these parameters for different materials, or the values rather. And Poisson equals 0.2. We have always the const loss, loss, which I will put on 0.3, and the frequency loss, frec loss, that will be also 0.3, I guess, yeah, for now. Okay, so that's our object created. We can compute the modes here, we can compute them here. It doesn't make too much of a difference. I'm gonna follow this example for now. So I will make it directly here. So modalis.compute modes. From this bowl, it's called, right? And I'm gonna also use this because this is not bad, because I can print this to the Max console, so this would show up. So if it's a basic if function, if bowl and the tilde equals means if it's not nil, then do. Right? So then print my bowl is awesome and ready to go. There. And we also here need to end this if function. And we are also going to return this bowl, not bowl. The bowel movement, no, the bowl, and have this whole function being called here. I can change now the modalis view. I will kind of cut it away here and put it in here and make it show us the bowl object. You will see what I mean. So I will copy this again, go over here, paste it instead of all this, close, save, evaluate. Oh, unexpected symbol near. Okay. Oh, of course, here. Oh, why did it do that? That's messed up. Okay, so I have it here. This was the bracket too much. Bracket. I'll take it again. Go back here. Open again. Oops. There. Paste it. Close, save, and evaluate. Okay, so now it calculated a little bit. My bowl is awesome and ready to go. So it showed up here, and it even shows already the blocked nodes here, which is great. So cool thing. Okay, we have our bowl. So now we can go over and create all the other jazz which is needed. So which we can see here. Let me just close that again. And so you can see here we have our object. It builds, it renders everything, and it's ready to be played on, but we still need to configure everything to play on it. So that's what we're going to do now. Here they also did this kind of in the same manner with the if function, just to be sure that it only does it if, because else I think I had Max crash on me if it was nil, and well, it can be a risk, right? So here I say if this final bowl object equals or is not equal to nil, then we can build all the stuff we need. So let's go. We need a local, so I will structure it a little bit differently than here. So first we need the mallet with which we are gonna strike the ball, right? So I'm gonna call it mallet equals modalis.create object. And this is gonna be kind equals b2 mass. That's the object we are taking. And the name is my mallet. There we go. So now we have our mallet. Now, after that, we can kind of make all our axes. If you remember, we need an axis, two axes of the mallet, one that touches the ball and one that we move. And we also need two axes on, at least two axes, but I'm going to make three axes on the ball. So one where it's hit and two where they have different outputs. So I'm first going to make the axis on the mallet and then the axes on the ball. And going to go through that. So if we look here, we have this create axis on the mallet, which we can make. And it's connected. So we have to look at which mallet is connected with this felt connection. So if you remember right, you need the axis on the ball where it's getting hit. You need the axis on the mallet which is hitting the ball. And you need the axis on the mallet which you are moving. It's because it's a B2 mass object. And the hitting part of the axis of the mallet, so the part of the mallet that is hitting the ball, and the part that is getting hit on the ball, they need to be connected through a kind of connection, which is here. And in this case, it's a felt connection, which is kind of a softer and more complex way of connecting, which simulate this felt on the mallet. So if we look into here, it has this axis in on the object itself here, and it connects it with the mallet axis 0, which is the part of the mallet which is touching the object, the 3D object. So I am gonna start out with making this this axis on the mallet. So mallet hitting, I'm gonna call it, equals to modalis.create axis there, and where it will be an axis on the mallet. The name of this axis will be, for me, I like to have it the same. Until now, I don't see a reason to not call it the same thing, unless I'm missing something. I haven't had problems with it until now. And the position is 0. If you remember right, this 0 and 1 needs a small and large mass, or the other way around. I would have to look it up again in the documentation. The next axis is mallet moving. So the part of the mallet that we are moving equals 2, and we can just copy that. And we are going to have it on the mallet, but we are going to call it mallet moving, and position 1. So this is what we will move. Let's go over to the axes on the ball itself. And this is where it can be really cool to have this, right? So now when we click, let's say I want to hit the ball here. I can immediately see all the nodes. So 3, 5, 6 could be one of these corners. So 3, 5, 6 would be, for example, a good access to hit it, let's say. So I will have a local bowl hit where it's getting hit. And I will again have the whole modulus and create access, but this time it's gonna be on final bowl. The name is gonna be bowl hit. And I need something more. I need the kind equals to normal. Name bowl hit, and the position, what did we say here? Shift 3, 5, 6. So I'm gonna put it here at 3, 5, 6. There, that's where it's getting hit. And we can also use 2 axes to listen to it stereo. So let's say we want, let's say we want here. So this is where we hit, and we want to have our outputs here. Let's say 329, and here 343. 329 and 343. So we can just copy that. 349 and 343. There we go. And this is, of course, bowl, I will call it out 1 and bowl out 2. It will also be on final node. It will also, here I will substitute these names, out 1 and out 2, and we have all our accesses that we need. Now we can connect them. So we need now 2 things. We need the connection between the mallet hitting and the bowl getting hit here. So that's the felt, and then we need the position controller, which basically is controlling the mallet moving. Right? Okay, so let's do that. We are also going to use the felt, so local my felt here, and this is modulus, as we can see here in the example, create connection there, and the kind equals felt there. The name, it needs a name, my felt, I'll call it. And now there are all the connections. So where 1 is where the bowl is getting hit. So bowl hit. Okay. And the initial position there equals to initial position 1 equals to 0. That's where that's positioned. So where the ball is hit is 0.0. The next one is where 2. So I will continue that in the next line, just for good measure. Where 2 equals 2. That's the mallet that is hitting, so mallet hitting. And the initial position 2 of that, we could take the same here, so 0.1. So that's where it starts off. Then there are all these extras, right? I will put them here. Thickness of the felt is 0.01, F0 equals 1. I'm just going to take the same values here. The alpha equals to 2.3. The epsilon is 0.1. 0.83, and the tau is 40 e minus 0.4. Okay, let's take that over like it is here. So we have our connection done. That seems to be all in order. And now we need to control the position. So that's in this line. So I'm gonna have the position here. Local mallet position. I'm gonna write it out. No, mallet pos should be enough. So modalis dot create, and the position is connection as well. Connection. So kind equals position. Next, where it is the mallet moving. That's where it is. And the name, I'm gonna take the same here, mallet pos. Is there anything else? Yeah, the weight. Okay, so weight. I'm gonna stay conventional here as well. 1, 0. 1 point. Okay. The last thing we need, we already have the accesses for the outputs, but we need to create the outputs. So I'm gonna do that. So modalis dot create point output, where equals the first one is bowl out 1, name equals bowl out 1. I'll take the same thing and I will put it on channel equals 1. And I'm just going to copy that and change it for the second channel. So bowl out 2, name bowl out 2, and channel 2. There we go. That's it. If the if function, of course, needs an end. There. And we should be good to go and evaluate that. Let's see. I could, so as you see with these comments, the common thing is the double dash. I will take that and put it here, view, final bowl, there. I will copy all of that again, go back to max, go in here, and the tension is as its peak. Let's save it, evaluate. Oh, there's of course a mistake. 41 and to close at 39. Okay, so there's, oh, I found it here, a comma. Something's missing. Okay, this was a mean one. Let's take everything again, go back here, paste it in with the comma, close it, evaluate. Aha, ha ha ha. Oh, it doesn't like that duplicate. Interesting. Okay, so now we see the bowl hit, and it's even written what's here, what's that, what's that. So that's great. I'm gonna change this if it really doesn't like the names. Bowl out 1, bowl out 2. Create output, output. Is it complaining about these two? I don't know, but I'm gonna try it out. Let's see. There we go. Save. Yeah, now it's not complaining anymore, and we have it. We have it. That's good. So it seems to calculate, it seems to do its thing. So we can now here jump up a little bit with no modes, so maybe 60 modes as in the example. I'm going to close it. I'm going to evaluate it again, and it seems to calculate. It doesn't have until now any kind of progression bar as how far it is in calculating, so let's see if that's a thing that might come. I would also love to see maybe an integration of being able to just edit the script in directly in Atom, but let's see. So I'm going to turn on the sound, evaluate it again. There we go, it's here. And I'm going to just borrow this controller, right? So this, it's, apply envelope. So apply envelope is one of the standard messages you can send to Modalis. Here, apply envelope. And mallet stroke is not quite right. In my case, the position controller is called mallet pos. So I have to change that. Mallet pos. Okay, so let's try. Oh, a nice sound. Works. Oh, joy. Nice. Really nice sound. So here we are. 3D objects with Modalis in Max. Seems to work like a charm. You'd have to be a little bit careful how you code, and Atom is certainly a nicer editor to stay clear and avoid mistakes. And yeah, so I hope you have fun with this, and see you maybe on the next one. Let's see. All the best.